This video is about creating selection sets and running an automatic electric placement. The three former steps from the device hierarchy over the device areas to the cable trenches need being completed before you can move to this step. When the field node gets selected, all requirement types or requirements for replacement can be set. The hierarchy is already pre-selected and shows a string inverter concept. If more than a single string inverter article is assigned to the device hierarchy, Helios will always pick the first one. That means the selection here is just necessary if a specific string inverter from the list should be used for a specific field. The placement direction will generate the wiring according to the arrow directions, like starting in the northwest. The position of string inverters gets optimized after the minimum total DC cable length. For that optimization, all connected tables or just the first table to the trench can be used. If larger gaps between the tables exist, we can set the distance for Helios to create connection trenches. So, cables are not lead through the air. Some designs use Y connectors as default for specific string definitions. Here we will not use them. The two checkboxes show different options to either connect strings from different module rows to different MPPTs or target devices, or to just connect strings from the first module row to separate MPPTs or target devices. The first one seems to be more likely now. For each array definition used in the layout, we need to assign the default string definition. I will use a U string for the half tables and for the regular full table linear strings. Then we move to the second page, cable trenches and device areas. The list of cable trenches just needs the first target trench for leading DC cables or string inverter out cables to the trenching system, further connection trenches to reach device areas or for connecting different areas as transformer station, and the grid shouldn't get added here. In my layout, I have a north and a south trench that go through the rows. So I add just the north and the south trench. In contrary to the cable trenches, the list of device areas requires all areas that are used to put the transformers or possible additional devices up to the grid connection to specific places. So here I add the public grid and the transformer station. The trenches and shortest routing between the areas here are determined automatically during placement. The placement itself is not executed for the field, but for so-called selection sets. If none of the settings we did for the field should be changed for a group of tables, a single selection set will work. We have 3 commands for generating selection sets. One for a single selection set and other options to split selection sets as according to the cable trenches. The entry, all free, just represents tables that are not assigned to an actual selection set, and the placement command does not work for it. So here I generate one single selection set. Now I can run the automatic placement for the selection set. As the number of strings doesn't match the exact number of inputs of the string inverters, we get a balancing dialog. So here I can match the open inputs for the last string inverter over a group of string inverters. For the selection set, the triangles on the tables can be hidden or shown. At the same time, I can show the strings on the tables. For a more complete result, you can switch to the electric structure page. Here the result structure with cable lengths and resulting losses can be analyzed. You can also display specific connections, like even for a specific string. Or you can show global relations as connections between modules and the string inverters, which can be displayed in different color schemes. My first layout is now complete and can be analyzed or manually changed. But this will be shown in additional videos.